Putting these splines together can be a little tricky, so you want to make sure you line them up. You can see this small section here is matched up with a wide section. You just have to pay attention to the key points for reassembling these back together properly and make sure it still has the proper pivot. So proper assembly and disassembly, and just making sure I stick with the standard way this was assembled and clocked into position. I use my engraver and just put a mark at the very top here, mark the cage housing, and this hub carrier itself right here. So therefore, when I put this in, all three of these notches will line back up perfectly into position, and I can make sure everything's clocked right. I'm making some progress. We installed the new hub onto custom drive shaft. So what I've done was take off the original housing that I had to cut off. There's a C-clip, so you have to clean. It's filthy, and I mean clean filth, meaning it has good packed synthetic grease in there, but it's a greasy job. So I had to clean mostly all of this material away. I didn't realize it was a snap ring clipped right here perfectly into this until I was able to look at the new one. So looking at this new housing, you can literally see that snap ring right there. So it was nice and clean, and that opened up the door for me to be able to clearly see without having to try to fight through all of that grease. I can clearly see how to pop that out. Once I popped out the snap ring, this housing just slid off with ease. So now all I have to do is just slide on the new housing, pop the snap ring back in, pack it with synthetic grease, zip the new boots back into position, and we'll be good to go. Okay, I checked out this hub on the inside, and it is identical to the original one with no taper at all. So I checked the inside of this hub to see if it was identical, and yes, it is identical to the original one. It's not tapered on the inside, which is not good for getting it off. It's good for keeping it into position. So for example, when that shaft slides into this hub, this piece is tapered. You can see it's got a nice taper wall right here. This will compress the C-clamp, allow the C-clamp to slide all the way up here when you push the shaft in, and then it locks into position, and there's no tapers here. It will lock in and stay in. So I could not get this off, and I had to end up cutting it off. So they sent me a replacement one. Of course, these brand new, they've been on the shelf, but they're not going to just take them off the shelf and modify them. Maybe that may be an upgrade for future ones. Who knows? But at this horsepower level, they want to keep it fixed in a position. Our problem would be if we had to take the axles off, swap the transmission, separate the bevel box, and for whatever reason, just take parts off the car, our axle hub here would be seized onto the bevel box transfer case. So for example, even the factory ones, you can see here, I brought this out for example, this piece is slid in. This doesn't have a locking ring, at least the older ones, like this one here. This had a C-clamp or C-ring in here where it snapped into position and it can stop it from coming back out. So when I even removed this one from the salvage yard, it was just a matter of snapping off the band, cut the strap off, slide this whole piece out. This is one of the things we have to be careful. This whole section right here allows travel. So in here, the bearing itself will travel up and down this whole housing for hitting bumps, just expansion and contraction, shifting up and down. You do not want this here, which is in much room, to slide off the end of the shaft. So this definitely has more travel than this little piece. So there's a potential that this could initially slide off. Therefore, I can kind of understand why it would be set up and fixed in position where it would come in and lock. But then you would end up with this. Worst case scenario, we could get it off. Now that I've taken this apart and I can understand how it is set up, if we needed to get the axles off the car, we would just take off the C-clamp, the C-ring, slide out the whole drive shaft, and this would be left on the housing. If we needed to get this off the housing, this little cover right here, I would just get a gear puller, shove it through the middle, press it, and have this wedged against the shaft. Pull, the jaws will pull right here, the threaded part will push here, and that would literally try to push this off of the shaft itself. So there is a way. But the downfall is we do not want to have to go through that. Now the original C-clip itself measures in at 1.9 millimeter. So for example, I get this out here, measure 1.9 millimeter, as you can see. So I found some wire, copper wire. It was a softer material, same thing, 1.9 millimeter itself, right there. Let me clamp it in different places. 1.9 millimeter. So it's the same exact diameter. So I can wrap that around. By being a softer material, it'll allow it to kind of compress or smash itself off if we was trying to press it off or pound it off. You can see right here the steel clip. This clip, it was trying to mushroom itself off to slide between, but this is so hard also, it continued to allow this to be locked into position. It would not come off. You can actually see the marks from the spline. They look like teeth marks that embedded in this when I was using 5 tons from a 5-ton press to try to press it out. It literally just locked itself into position, had no choice but to result and cut it off. So with the copper, that is a lot softer material. Like for example, this is real hard. It's still hard to even bend. The copper is softer. That will allow us to be able to compress and pound it off, and the copper, by being softer, it will mushroom enough to allow this possibly to press off. It'll still do its purpose with letting it slide into position and lock in, because making high horsepower, we don't want to take the chance of it popping off either. But the copper will at least allow it to slide up into position, lock in, and keep it fixed into that position. Of course, copper can handle a lot of heat as well, so we don't have to worry about that material melting. But then it is soft enough that when we apply enough force to it, it may let it compress and just break itself down and just slide itself all the way through and come out. So I'm pretty much going to go with the idea of using a copper C-clip in position to go on to the end of my original shaft that goes into my bevel box for sliding it into place and locking this up into position. I literally used my bore scope to look down into this hole to make sure or see if they tapered it before I did any type of modifications. I literally have a head that's used for a cutting wheel. This is used for grinding tungsten. So it's strong enough to kind of get in here and taper this, because I was going to come down and taper the edges around to give it somewhat of a taper similar to this, as you can see these tapers, to allow it to be able to compress the ring enough to come off. But you don't want to really get into cutting too much. If we have to, if this happens another time, we will be using a wheel to kind of cut into here and try to taper it as best as possible. But for now, we're going to use the copper for locking it into position, and hopefully we won't have any issues with that. But the primary concern was getting this seal cover on. So as you can see, this has a cover over here that's covering the seal. We wanted to get this seal cover on the end of this, so that way it protects the seal, the factory seal, on the original bevel box. So I just cut my wire and rolled it into a circle. I actually used a socket to kind of roll it around, and I tapered these ends down a little bit more, so that way if we have to remove it, they won't stick up in the air and kind of bite into this slot right here to still give it a little room. They'll be laid down, and it allows the outside diameter to kind of compress to allow it to slide off. So I'm going to wrap this around this shaft and we'll snap it into position. Also, another note is this is actually a softer steel. So this is a hard steel. This steel would not budge at all. You can see the spline marks in here. This softer steel, the whole point of this, using this material is, at first I thought it was copper. Once I stripped the cover off it, it's actually a coating protection that's on this steel also. So we don't have to worry about anything like this melting or being wrapped around here from any type of friction welding. But the purpose is to allow this to snap into position and kind of stay in place without sliding back out. I have the new C-clip on the shaft, and it's turned out to be pretty good. because if you look carefully here, this can't go below the groove that's been machined into the splines to allow it to go off, but it still has enough spring to stay above the shaft. And as you can see, once it's compressed, this other side springs out, but that's enough to allow it to still lock itself into position, which is great. It has enough spring to keep itself expanded, but hopefully it's still soft enough if we have to remove it, it will compress, unlike this factory spring that just did not want to compress at all. It just literally bit into the splines and just froze itself into position. But at least this will at least lock us into place and give us a better chance of removal in the future. Hopefully we won't have to take it off, but if we did, we can go through the process of trying to tap this off, this cover off like we would normally do, which shouldn't take no more than a few minutes just to get a soft mallet and pound it off. It should snap off position. If not, if it's frozen into place like a few of the ones from the factory that freezes onto the bevel box, we can then pop out this snap ring right here and take that out and just slide the whole shaft out like this. Leave this fixed onto the bevel box and continue to do what we need. Pack a little grease back in here, shove this back into the slot, put your clip back in, and of course seal your boot in place, and then just keep rolling. We're looking good so far. Have my C-clip back into position. I have the front half of this housing packed and full of grease. Have my seal cover on, and I'm going to use the remainder of the grease and pack right around here. Slide my boot back up into position, and then clamp everything down, and this bad boy will be rebuilt and ready to go again. Looking pretty good. It started raining. As you can see, a little rain on the cart, but I persevered and continued to work. I have my boots and everything strapped into position. You can see this side where they strapped it so tight, you can see the rubber was starting to bulge out. So I still strapped it tight. You can see any type of grease that was in here just started squeezing and oozing out of here because I got the clamp nice and tight. So that is pretty good. I can still go a little bit tighter, but one of the things that I dislike about going too tight is once you start clamping really tight, it tends to want to cut itself into the boot. So as long as it's tight, it does have a ring, a bevel around here that will lock itself into position. So this is tight enough to keep it coming off. Some people use zip ties. It works. It's a little cheesy, but it works. But of course, the metal band straps is the best way to go. Now to understand why they sent me a few spare boot clamps. So I used my boot clamp tool. I was trying to squeeze it in super tight because like on the smaller end, they got it squeezed so tight it's almost touching right there. So I tried to squeeze it in very tight like that, and the tabs gave way. You can see where I had it compressed in very tight. My tabs gave way and the strap popped off. So I should have stuck with my own experience level, and I can't complain because I do got more experience now knowing how much force I can apply to these. So I had it right the first time. I took it to a point of failure. Now I can go back and I do have a good reference point of how far I can strap this with how much force. Either way, like I said, you can see the grease oozing out. It's very nice and tight. It's a ridge inside this anyway. That's when I'm locking in place and not allow it to slip off. So it's on there, nice and good. We don't have to worry about popping off. And I used the tools that they supplied me with, the straps or the parts that they used me with, and I had my own tools. So you can see here on the shaft, I have the new C-clip. It's a softer metal, but it's definitely going to be above the lines of the splines. So this will definitely lock itself into position, and it still has plenty of spring. So as I compress it down, it springs right back up into position. You can see that anytime I push down, it'll slide down and spring back up. So it's definitely going to lock itself into position like it should. Just hopefully we won't have problems removing it when it comes time to change anything. But it is a softer metal. It is a better opportunity of taking this off than it was before with that fixed C-clip. This C-clip is such hard steel that using a 5-ton press would not allow it to come off. You can see the teeth mark from the splines that bit into it, and it wouldn't even let it slice itself off. But with the softer material, hopefully if we go into that problem where we need to remove it, the ring is soft enough so that the splines would cut through this material, the softer material, and allow it to slide itself off. So in either way, I've played with this and now I have experience taking this apart. I know how they have this designed and what I can do, need be, if we have a problem, take this whole assembly out, get a puller, use a puller, and press against this shaft with the jaws against this, and we can get it off that way if need be. So I cleaned up all the grease and all the extra material, so that way now we can go ahead and finish back off where I tried to start a few months ago with putting this, and it's been, well, a month ago, putting this front axle back in position. So originally the culprit was getting the cover, the grease cover. We did a test fit. This slid onto the shaft and locked itself into position. So we got everything rebuilt with a new hub assembly, CV hub, and because they sent me the front part, had to cut the old one off, and we'll be ready to go. So I like these clamps a lot better too. They sent me these, and they use them also in this part of the axle, but you can see right here they use this other type of clamp right here. I like these. I have the tool for both, so I use mine and my extra ones here. They may have not known I had the tool for both, so they just sent me these type of clamps right here, boot clamps. But either way, they use these on all the CV joints anyway. This one and this style also. I tend to, as I said, I like these a little bit better, and plus it's a lower profile in certain areas. You don't have to worry about these nubs sticking up high enough in tight locations and catching onto something. So let's get this bad boy back into the car where it belongs. My objective is to get this in, and it's raining again. This is crazy. Look at, it's just my objective is at least get this axle in, and I would like to accomplish that today, so I'm determined to. But my ground is getting wet. I want to get this bad boy back in the car, and we're going to keep fighting with it. Okay, she snapped in there good, as she should. Pushed forward, and it snapped onto the shaft. So we're picking back up where we left off. We can get this whole assembly, the axle bolted back in, tighten down my support bracket for the bevel box, and go ahead and connect all of this to our Verkline suspension, bolt everything back in position, and let's go. I'm bolting the suspension and the axle back into position, but I wanted to give a good reference on how the measurements turned out. So they turned out very great. The car, of course, is off its suspension, is elevated in the air. So you can see right here, it has a little bit of play. Right now, if I force my shaft all the way back, it's all the way up against my housing. And you can hear it thumping. And then if I force here, I'm making contact right here. So once I bolt this axle back, the axle nut back in position, it's going to bring this forward just a little bit, almost off of that back wall, meaning like overhead right here. If my bearing housing is back up against the stop here, when my car is lowered back down onto a suspension, right now it's pulled probably somewhere right around here. And when it lowers back down into a suspension, it's going to move back and will be somewhere right around here. So that's the optimum point you would want to be with making sure your bearings and everything is centered. So therefore, when the car hits a bump and the springs are compressed, it's going to force itself in. If it raises up, it's going to shift this way. And in a neutral position, you're going to be riding somewhere in the center. Turned out pretty great. So I finally have the front passenger axle bolted into position, have my control arm bolted in, my suspension link, Verkline, control arm, everything's hooked back up into place. Mission accomplished. So I weathered the storm literally. So this is in position. Everything turned out great. Good to go. Now I can go ahead, secure my bevel box bracket, double check all my torque specs on my bevel box, make sure everything is bolted in position and securely tightened, and then we can pick back up with putting the exhaust manifold and finish with the fabrication.
You're trying to stay strong and fake a smile until